Hello, calculus. Tomorrow in class, we're most likely going to go over our quizzes, assuming I get it graded tonight. But just in case, and so that you have 2 days to digest these notes, I'm going to go ahead and make your um, videos for limits of trig functions. I talked to first period, and I think we're going to change the format of how we do this. They like the flipped classroom and that they get to watch the videos at their own speed at nighttime. But they wanted to do the problems together in class instead of in groups. So that's what we're going to do. I think it's a great compromise, and maybe at some point we'll do some activities where it kind of challenges you. But for right now, we're going to go ahead and do the problems together. All right, so we've talked about how we evaluate limits of trig functions by direct substitution. So let's practice that just one more time here. I'm just going to plug in 2/3. Well, I guess I don't need this. Plug in 2/3 everywhere I see theta. So sine 3 times 2 pi over 3 over 3 times 2 pi over 3. My 3's cancel. That gives me sine pi over 2 pi. Well, my y value at pi, remember pi is over here, the y value is 0. So this would be 0 over 2 pi, which would be 0. The second one here, I have 2 cosine squared of pi. Some people don't know that. That's the same thing as 2 times cosine pi squared. It just means 2 of these guys. Well, cosine pi again, here we are. Oh, sorry, I lied to you before. I heard you were screaming at home. 2 pi is over here, Miss Harris, but the y value is still 0, so yay. Over on here for cosine of pi, we're over here at this point. My x value is -1, so this is 2 times -1 squared, 2 times 1. So our limit there is 2. So each of these functions that we've talked about so far, we were able to plug in our theta and evaluate it algebraically. However, sometimes this is not the case, even when we're talking about trig functions. So, for example, if we plugged in 0 here, I have 1 minus cosine 0 over sine squared 0. Oh, keep wanting to write data. Sine 0. Well, cosine 0 is 1, and sine of 0, the y value of 0 is 0. And so this would be no bueno, right? We can't have 0 over 0. Well, what did we do when we had 0 over 0? Remember, we had factoring. We could use rationalization. I feel like there's one other factoring rationalization. Can't think of the last one off the top of my head. But if we have a trig function, well, there's nothing I can really factor here. Can't really rationalize it. I could try like 1 plus cosine theta. But what else do we have with trig functions that we don't have with other functions? All of those trig properties. Remember those guys? Oh, no, Miss Harris, we don't. Well, that's a shame because I told you you needed to memorize it. So here we go. So if this is my original problem, it's kind of here, right? I'm going to rewrite sine squared theta using my identity. And that'd be 1 minus cosine theta. Well, sine squared theta is the same thing as 1 minus 1 minus cosine squared theta. And now I've got a difference of squares. So this is the same thing as the limit. Theta goes to 0. 1 minus cosine theta on top. On the bottom, I've got 1 minus cosine theta, 1 plus cosine theta. Just fortunate. The pesky 1 goes away. Now I've got the limit as theta approaches 0, 1 over 1 plus cosine theta. Now I can plug in that 0. So this will be 1 over 1 plus cosine 0. Cosine of 0 is 1, so 1 plus 1 would be 2. So I got 1/2 there for my limit. Alright, so at this point you might be going, okay, where's the draw form? I don't remember. There's trig identities. Don't stress just yet. Let's talk about the ones that, if you had these memorized, you should be able to do the majority of your AB test. So let's go ahead and just start by rememorizing these guys. Sine squared theta plus cosine squared theta is equal to 1. That's the one that we used up here. So remember, if I wanted just sine squared theta, I could move the cosine squared theta over, and I've got sine squared theta is actually 1 minus cosine squared theta, which is what I did here. I could do the same thing for cosine squared theta if I moved sine squared theta. So it's really one identity, but you could get 3 identities out of it. 2, we need to remember tan theta. It's the same thing as sine theta over cosine theta. We need to remember cotangent theta is the reciprocal of that, so cosine theta over sine theta. Secant theta is what? 1 over cosine theta. Cosecant theta is 1 over sine theta. And then here's the big one. This is the one that I still probably don't have it memorized. Sine 2 theta is the same thing as 2 sine theta cosine theta. There's a couple other definitions I'm going to say, or identities for sine 2 theta, but this is the one that you're going to see most frequently. All right, let's see if we can do a couple of examples where just using trig identities will help us find our limit. So here I've got 3 tangent theta cosine theta, and we're finding the limit as theta goes to 3 pi over 2. I'm assuming that if they're giving us this one, it probably doesn't work out well somewhere in there. But let's go ahead and rewrite it using our identity for a tangent. So in fact, I've got a 3 out here. I'm going to pull the 3 out front from the very beginning. So remember that the limit of a number, you can pull that number out in front of the limit because the limit of the number is just that number. So we can pull that out of the mix. Tangent theta is sine theta over cosine theta times cosine theta, which is just cosine theta over 1. Here we go. Cosine thetas go away. So I really have 3 times the limit as theta goes to 3 pi over 2 of sine theta. And that's going to be 3 times sine of 3 pi over 2. All right, where's 3 pi over 2? Remember, this is pi over 2 pi. 3 pi over 2 is down here. That's the point 0, negative 1. My y value, my sine value there is negative 1. So 3 times negative 1, our limit here is negative 3. All right, number 2. This is going to be the limit as theta goes to pi over 2. Secant is the same thing as 1 over cosine theta times cosine theta over 1 all over 4 theta. Here my cosine thetas cancel each other out. So I've got the limit as theta goes to pi over 2, 1 over 4 theta. It'll be 1 over 4 times pi over 2. And 2 goes to the 4 2 times, so it's 1 over 2 pi. Alright, number 3. Let's see, limit as theta goes to pi. I've got cosine theta times tan theta. Well, tangent theta is sine theta over cosine theta. All over sine theta. Remember, this guy's really over 1, so cosine thetas cancel. And that gives me the limit as theta goes to pi. That's sine theta over sine theta. The sine theta over sine theta cancels, so that just gives me the limit as theta goes to pi of 1. The limit of any number is just going to be that number. So our limit there is 1. All right, that's the first video. I'm going to come back. We're going to explore 2 special trig functions, 2 special limits of trig functions, and then after that we'll work through some more problems.